Morning all. Today in electron devices and circuit theory we'll see the construction and working of MOSFET. Okay. So you are familiar with BJT. BJT is bipolar junction transistor. Okay. Here we will be seeing about the MOSFET. MOSFET is metal oxide semiconductor field effect transistor. Okay. So here you can see the representation of the MOSFET. MOSFET, it is having mainly three terminals. Mainly it is having four terminals. One is the source, one is gate, one is drain, and other one is subtract. Usually this body or subtract and the source, it will be connected together. So in while we are seeing the MOSFET, we will be seeing about the three terminals. It is the source, drain and the gate. The three terminals will be there in the MOSFET. Okay. So depending on the construction, either here source is there, so either here you will be having two N channels will be there, two N type semiconductors, it will be diffused in a P type subtract, or you will be having two P type semiconductors, two P type semiconductor materials which will be diffused in a N type subtract. Okay. So there only our construction difference. So mainly we are having MOSFET. The types are enhancement mode and depletion mode. In enhancement mode we have P channel and N channel MOSFET. Similarly in depletion mode we have P channel and N channel MOSFET. Okay. So if it is a P channel MOSFET means the channel between here, this channel will be the P. That means here we will be having a lightly doped P type subtract will be there, and you will be having two heavily doped N type subtract. The channel formed between the two subtracts will be of the P channel if it is a P channel MOSFET. Okay. So if it is a N channel MOSFET, here you will be having the channel which is formed between the two subtracts will be of N channel, where we will be having the two here, these two will be the heavily doped P type subtracts, okay, which will be diffused in a lightly doped N channel subtract. So that is the difference between, mainly difference between the P channel subtract and the N channel subtract. Okay. Now the major classification of MOSFET is metal oxide semiconductor field effect transistor is enhancement and depletion. So before that you are having the, here you will be having this from the source directly, you will be taking the terminal, metal contact will be taken from here, one terminal, one of your N subtract you will be taking the drain terminal, and from here you will be having the base or the subtract. Okay. So in between the two you will be having a gate terminal, but the gate terminal directly it is not taken from the semiconductor, it is taken with an insulation. So here you will be having a SiO2, SiO2, this white surface you can see, a silicon dioxide will be grown in the top of that. From there you will be having a metal contact and the gate terminal will be taken. Hence the name, this is metal. So here this is metal. Here this one is this white color. This one is the silicon dioxide. Okay, metal oxide. Here you will be having the semiconductor material. Hence the name you have metal oxide semiconductor field effect transistor. Okay. So first of all we'll see about the enhancement MOSFET. So what's an enhancement MOSFET? In enhancement MOSFET there will not be any channel, that is it is presently it will be in the off condition unless you are not giving any signal to the gate terminal. So your device will be on only if you are giving voltage to the gate terminal. If there is no voltage across the gate terminal, your device will not conduct and there will not be any channel of, or the any current flow will be there between the drain and the source terminal. So here you can see this is your, so gate is insulated, so this terminal is the gate terminal, So here you have this one, this is your so drain terminal, and here you will be having the source and the body. Source and the body will be short circuited. Okay, so this is for P channel MOSFET, and here you are having for the N channel MOSFET. Okay, so this is your diagram for the enhancement MOSFET. So two N-type heavily doped semiconductor will be there. It will be diffused in a lightly doped P-type substrate. Okay, so there will not be having any current flow, or there will not be having any free electrons between the source and your drain. Okay, so that is enhancement. So once we are applying, so now you assume that since we are not applying any voltage across the terminal, what will happen? Your there will not be any, your MOSFET will be in the off condition. So now when you are giving voltage to the gate terminal, what will happen? The channel between the source and the drain will be less resistive. So we are increasing the voltage in the gate. So increase of voltage in the gate, the current flow from the terminal due to the drain to source will be increasing unless it is reaching the maximum point. So unless it is reaching the pinch of voltage means what? After that your current will be get saturated. Okay, so more or less your enhancement MOSFET is behaving just like your bipolar junction transistor. So here first condition, we are assuming that we are not applying any VGS, gate to source voltage we are not applying, only we are applying positive voltage to the drain and source. Okay, so when you are applying positive voltage to the drain and the source, your p-type subtract of the two n region will behave like a 2 pn junction, and both the junctions will be under the reverse bias condition, and there will not be any current flow between the drain and your source. So now when you are increasing your source voltage, when gate source voltage, what will happen? The minority carriers which is present in your p subtract will be attracted towards the positive terminal of the gate. So once it is attracted towards the positive terminal of the gate, it itself form a channel between the drain and your source. Okay, so this accumulation, it forms a channel between the drain and the source, and once it is a channel is formed, you will be having the current flow. So here you can have the drain characteristics of the enhancement MOSFET. So drain characteristics is drawn between the drain current and your drain to source voltage, keeping your VGS constant. So once here you are applying the positive VGS, once you are once VGS voltage is keep on increasing, your current value will also start increasing. It will have a linear relationship up to the ohmic region. After that you will be having your current will be saturated. Even though you are increasing the drain to source voltage, you are increasing, you will not have any further increase in the current value. Current will be get saturated. Okay, so that's all about your enhancement type MOSFET. See you in next video. Until then, bye bye. Very drastically, but the output voltage will remain constant.